Recording. Hi everyone, this is the, what day is it? It is, I should have looked that up. It is April 10th. This is the SIG API machinery meeting. We are doing a special edition. Jordan is going to tell us all about Go modules. So Jordan, please take it away.
All right, let me share my screen. I think you need to stop.
Yeah, I think you have to stop sharing.
There we go. All right, can you see that?
We can, yes.
Great. All right, so this is a whirlwind tour of Go modules. All of the examples and links and everything will be posted after the fact, so don't worry if you miss something. All this will be available for you. I also want to just declare up front, this is my current understanding. I've spent the last several weeks or month or so digging into this. It is entirely possible I've misunderstood something, so I reserve the right for published errata afterwards. All right, so very quickly, you're all probably familiar with the old way, which is Go path. So that's where all your source code is located in one tree, and all your modules have to be in that one place and are relative to each other, and it's kind of one big ball of code. And so if you had a couple components, it might look like what you see here. So I've got this one component, which is my main function, and it has a sub package with a helper that prints some stuff. And then it also depends on this other component, which is pretty useless, but we're definitely going to call that function. And all of these live underneath my Go path. So they must be located relative to Go path by their import path. And so when I run this, it works. And what happens when I run that? Well, Go starts with my main package and then resolves all of its dependencies transitively until it's resolved everything that's required for the build. Then it builds that and outputs the result. So what's nice about this? Well, it's hermetic-ish. We're not talking to the network. All the source that's required for this build is located on my machine. No network access is required. It allows me to develop locally. It lets me work on this component and this component at the same time and make changes in one and then build, and those changes are reflected in the build. So there are a few things that are nice about that, but there are also some potential problems, like what if I have multiple things in my Go path that need different versions of this component? Well, we don't really have a way to deal with that, and so what you usually have to do is have completely different Go paths per project. Or you can vendor all your dependencies into a vendor subdirectory. Neither of those are super terrific. You end up with lots of duplication, and it's kind of hard to manage. Another potential problem, what if you don't want to structure your directory tree like Go path requires? Well, tough. You don't always get what you want. And then finally, what if the source in Go path drifts from its authoritative source? So I mentioned before, like I can develop locally, I can change stuff under here, but what if this wasn't a component I owned? What if this was like CAdvisor or glog or something like that? If I change that, it definitely gets reflected in my build, but it's easy to accidentally drift from the authoritative source. So that can be good or bad depending on whether you're counting on developing locally or not. And so then finally, a few questions about how Go resolves paths. If Go is trying to figure out what the full import path of that is, the way it does it is looks at its relative path to Go path. So that's my Go path. And so it knows when it's looking at this Go file, oh, well, your import package is github.com/liggitt/b. Another question, when I'm building my main module, my main component, what version of B does it use? And the answer to that in Go previously was, what's a version? There's no concept of versions in Go prior to Go modules. As far as distributing stuff, you're probably familiar with go get. You run go get and give it a resolvable package, and Go will go download master of that package along with master of any transitive dependencies. So that works great as long as nobody ever breaks compatibility, and master is always what you want. All right, so Go modules, the new way. Let's try removing these from my Go path and see what happens if I build them somewhere else. So I'm going to check that same A repo out in some random path. So I just made up a path, cloned it into there, and now when I try to run, you get the error you would expect. You're trying to build something that's outside of a Go path, and Go has no idea that the helpers folder is actually this package. It has no idea how to find the other B component that I needed. So let's turn this package into a Go module. And so the easy way to do that is to run go mod init and tell it the full package to my module. And once we do that, it creates a go.mod file for us. And there are a couple things in here. One is it declaring the full canonical import path of our module. And the other is the version of Go that we are expected to build with. So that's actually all we have to do to define a module. And now if we try to run, it actually works. So Go was able to figure out, looking at this directory and the subdirectories, that their fully qualified import paths were prefixed with this. So instead of figuring it out relative to a Go path, it figures it out relative to the declared module of the closest Go mod file. So the helpers subdirectory, if it's trying to figure out what the package of that is, it walks up the tree until it finds this Go mod file, says, oh, this is declaring this module, therefore that must be github.com/liggitt/a/helpers. That is the path of this helpers package. But it actually was able to locate github.com/liggitt/b, which is interesting. So let's look at what that actually did to our Go mod file. When we ran, Go noticed that we were importing a package that wasn't represented as a dependency in our module file. And it resolved that, found that the current tagged version of that was v1.0.0, and it added it to our Go mod file automatically as a require statement. So the syntax of require statements are the dependency that you're requiring, and then the version that you want. And this is actually the minimum version that we want. This says that we require at least version 1.0.0 of this dependency. That'll be important later. One interesting thing, if you're trying to read a Go mod file, just like import statements, you can have each on its own line, or you can group them into a block. So multiple require lines or several in a block are equivalent. And the version that can be specified there can be any tag or branch or SHA, anything that Go can resolve from version control can be put there. And the next time that Go resolves the module graph, it will turn it into its canonical form. So if you want to specify a particular SHA or branch, you can do that. You can also, so when we did this, we just said go run, and it found the latest version of this module. If we had a particular version in mind, we could have used go get to express this and specified a particular version, and it would have added that require statement as well, rather than just automatically grabbing the latest. So this adds the ability to specify versions as part of go get, which is nice, instead of always grabbing master. All right. So it recorded that we required this version, but then if we don't have a go path, where did the B dependency actually get put? And it got put in a module cache, which is located under our go path. And you can look at it as just a directory full of files segmented by module path. And you'll notice that the version information is recorded. So we no longer have the problem with not being able to hold on to multiple versions of a component. So if we were using 1.0.0 and someone else was using a different version, those could be cached side by side. So this cache is maintained automatically for us, but it has a few commands that you can use to manage it if you want. So you can clean the cache, empty it out, running go clean -mod cache. On the flip side, you can force Go to download all the dependencies into the cache by running go mod download. And you'll see it finding and downloading it again.
Jordan, can you make your window just a little bit shorter? We can't see the bottom, so we can you're typing.
How's that?
Ah, perfect.
Okay, great. Now, you might be looking at this saying, but I love my hermetic builds. I don't want builds talking to the network at all. And if that's you, there are tools for you. The Go proxy environment variable controls whether or not, controls where Go looks for modules when it can't find them. And there are a few options. The default, if it's unset, is to go talk to the network and try to resolve things from version control. But you can explicitly turn it off. And if you turn it off and try to do things that require resolving modules, and it's blocked by turning network access off, the operations will fail. So to demonstrate that, let's run this again. So we're running, and we had already downloaded stuff, so this ran successfully. If we turn network access off and run, well, we've already downloaded things into the cache, so we don't actually need network access anymore. So this works as well. But if we empty our cache and then try to do the same thing, so we don't have anything cached anymore, and we've told it you may not talk to the network, but we're going to try to run and resolve this stuff anyway, well, now we fail. It says it can't look up the module because we cut off its access to the network. So that is how Go manages cached modules by default. If you are used to vendoring all your dependencies into your repo and checking it in, you can still do that as well. So there's actually a tool built into Go now, which will take all of those dependencies, the particular versions that you depend on, and put them into the vendor dir inside your project. So that is really nice to have that built in instead of having to use some third-party tool. And the version resolution that uses matches the same version resolution used by every other Go tool. Build, run, test, everything is using the same version resolution. Now, once you have this vendor directory, Go does not use it by default when you are in module mode, which there are open issues about and discussion about changing behavior. So if you, even though I have this vendored, if I did that experiment again and turned off network access and ran without a cache, it would still fail. You have to explicitly tell it to use the vendor directory when you're in module mode. This is all current as of Go 1.12, so we'll see if that changes in the future. So I have no module cache, I have no network access, but I have told Go to use my vendor directory, even though I am using modules. All right, so some benefits of this are that dependencies don't drift from their canonical source, right? The module cache actually checksums the dependencies as it pulls them in, so that if you went and monkeyed with stuff inside that directory, it would actually complain about it. Another benefit, there's some control with Go Get about what version you pull in. And finally, there's built-in tools for caching and vendoring and ensuring a hermetic build with no network access. So those are all things that are nice that we didn't have before Go modules. The sync before we move on. All right. As far as distribution, if someone wanted to get a particular version of your module, again, they could run go get, and they can now specify a particular version instead of just grabbing master. And when they do that, the versions that you depend on, your transitive dependencies, get those preferences are used by Go as well. So go get no longer just automatically grabs master of everything. There's version information and transitive dependency version information available to Go, which is great. All right, so now we've got this module pretty simple. Let's see what happens when we try to do some more interesting things with version requirements. So let's add a new dependency. So I've got another module that I'm going to add, and I'm going to record that I intended to use it. And if we look at what got recorded, we notice this indirect decoration. What that means is we said we wanted to use this, but we're not actually using it yet. We have no imports that use it. And so Go tooling throws that on there to say, like, you recorded you want to use this, but you don't seem to be using it directly. But let's actually use it now. So we'll import it, and we will call this method from it. And so now once we save that and run, coding live is great. All right, so we're now calling this method, which is great. If we look at our Go mod file, we notice that the indirect decoration got removed because we're actually importing this thing and using it now. It's a direct dependency of ours. So that's great. So we said what version of this thing we wanted to use. Go handled downloading it. It's in our module cache. Great. So now let's add another dependency. And this is where everybody who has ever done anything with dependency management says, but what about diamond dependencies? Yes, yes. And let's say we're going to use version 1 of this new dependency as well. All right, so now we're going to run And oh, wait a minute. The method that we were calling from module C changed. Why did it change? Like all we did was add D, and let's figure out what's going on. So if we look at our Go module, the version of C that we are requiring has been bumped up from 1.0 to 1.1. And this happened silently without us knowing about it, which is super annoying. But let's figure out why it got bumped up to version 1.1. Go gives us tools to look at the graph of dependencies. If we run go mod graph, we can see all the modules that are involved in a build and what versions they require. And this right here is the culprit. So this new thing we pulled in required version 1.1 of module C. And if we go look at the definition for that module, we can see, yep, right there, it's requiring version 1.1.0. Now maybe it had no particular reason for requiring 1.1.0. Maybe that just happened to be the latest, the current version when they wrote this. But the way Go modules work, everything involved in a build expresses a preference for a version, and the largest or the newest version is selected. And so we wanted 1.1.0. This module wanted, we wanted 1.0.0. This module wanted 1.1.0, and so the biggest version won. And you might be wondering why that got reflected back into our Go mod file. So the intent behind that is to avoid misleading require statements in Go mod files. So if a newer version would actually be selected by Go, it will, whenever it builds the module graph, it will reflect the actual versions that are being used back into the Go mod file. So on the one hand, that's helpful. You don't have to go dig through a bunch of stuff to figure out what the Go version resolution already knows. On the other hand, that's kind of crazy making if you're trying to actually pin things down and you don't like things shifting out from under you. There's a really great issue open in the Golang repo that talks about the number of side effects is more than it should be, which is 0. Anyway, back to our use. We really don't want that new behavior, right? Like this is no good. We don't want or death. We want cake. And so we should be masters of our own destiny. We are the top level module. We are defining this build. We should be able to force 1.0.0 to be used. And so fortunately, Go modules give the main module a way to do this. And that is with a replace directive. So the require directive says, I want a version at least this new. Replace directive lets you say, no, it must be exactly this version. And so there's a command line tool called go mod edit that has a bunch of options. One of the things it lets you do is specify these replace directives. And the structure, when you want to pin a version, you say which module you want to pin, which module you want to use, and what version. And when we run that, that shows up in the Go mod file like this. So on the left-hand side, you have the thing you want to replace, and on the right-hand side, you have what you want to replace it with. In our case, the thing we're interested in is replacing with a specific version. And so if we run, great, like we're back to the behavior we wanted, even though one of our transitive dependencies had expressed a preference for a newer version. Now, all the normal caveats apply here. Like if there was an actual incompatible change, or there was behavior that in the new 1.1.0 version that it was depending on, obviously this wouldn't work. But in our case, none of that existed. So we were able to pin to a version and not break ourselves. So a couple caveats about these replace directives. The first one is they only work in the main module. So if you are running the build for a command, if you are defining the main package, then that's great. But if you are defining something that's intended to be used as a library by other people, putting replace directives in your Go mod file isn't going to do anything. Those will be ignored when your library gets pulled in as a dependency in another build. So be aware of that. Don't count on using those for anything other than the main module. So we talked about the format being the thing you want to replace and then what you want to replace it with. There are a few different use cases for replacing. The first is the one we looked at, which is pinning versions. Here we go. Pinning to a particular version. So in this case, the left-hand side and right-hand side are the same. All we're doing is forcing a version. Another way you can use replace directives is to point to a fork. So if you wanted to make a fork of something and then make some changes and then build or test with that, you can actually tell it, find the source for this thing here. So that's really handy. You don't have to rewrite imports. You don't have to do anything like that. It tells Go where to find the source for that. Now, the thing that's located at this location must actually be a drop-in replacement for that. Again, no import rewriting is done for you, so it must be source compatible. But this is really handy for testing with a fork of a dependency. And then the last thing that replace lets you do is point to a local path on disk. So the left-hand side is the import package of the module, and the right-hand side is an actual relative file path. And so if you were wondering, like, how do I develop multiple modules at the same time? I used to do that in GoPath, and now it's going to like check some stuff and not let me modify it. Well, this is how. You set up replace directives that point to the peer folders on disk as you're doing your local development. You have to remember not to commit those, which is kind of annoying. I haven't found a great workflow for doing this in a non-temporary way. So before you actually commit and push the Go mod file up to source for other people to pull down, you would want to drop those. All right, so to wrap up, what about major version incompatibilities? So we looked at a case where we wanted to pin to a version, but that was a compatible version. Like we disagreed with our dependencies about which version to use, but they were signature compatible. So what about incompatibilities? Go modules give you a way to do this. It's not as magical as you might hope. Basically, if you make an incompatible change, you also need to change the import path of your package. And Go modules do this with an affordance that signifies like a major version. So here's an example of an incompatible change we wanted to make to this signature. And to do that in a way that could be consumed by, so that our old and new version could both exist side by side in a build, we have to change the import path of our package. And that has all the implications, all the ripple effects that you would expect. It means that all the consumers that you have also have to change the import paths that they use to import your package. And so switching to use version 2 of this module would look like changing which version you required. So you see the name of the module actually changes along with the version. And then all the import paths that you would expect to refer to that module with also change. But the upside of that is that it allows two incompatible versions of the same module. You put the same module in scare quotes because it's actually a different import path. It allows them to exist side by side and actually compile and run. And if we look at the graph, we now depend on v1 x of module C, and D now depends on v2 of module C. And it's using functions with different signatures, and they can coexist in the same build. So a couple benefits of that: allows side-by-side use of different major versions. One interesting thing is that v2 of the module could actually use v1 of the module if it wanted to. So a module can import a different version of itself. It gets a little squirrely, but if you didn't want to maintain the same logic in a lot of places, you could do that if you wanted to. If you're looking for magic, you're going to be disappointed. There's no magic. You could almost do the same thing with just creating a v2 package. The things that this gets you are some niceties around go get understanding versions and some things like that. But it's not that different from just creating a v2 package. This works best for shallow modules. If you have a lot of internal imports in your module and you want to bump major revisions, you're going to have to rewrite all those internal imports as well. All right. So then just a kind of a whirlwind list of links and resources. There's a lot of help topics in the Go command itself that talk about modules and the Go mod file and the mod command and how Go get changes to be module aware. There's details about the Go proxy environment variable that lets you point to a folder on disk or disable network access when resolving modules. And there's also a link to the Golang wiki. And then finally, just a bunch of kind of different recipes. If you're using Go 1.12, which if you're developing for Kubernetes, you must be at this point, you actually have to opt in to using Go modules. In Go 1.13, they'll be on by default. But if you want to run the stuff that I showed here, you need to opt in by setting this environment variable. We looked at how to initialize a new module. There are a few commands that let you see the module graph and will tell you why a particular package is imported. Some of these, like Go list, already existed, but now they have module-aware variants. Before you commit anything that uses a Go module, you should run go mod tidy. That makes sure everything in the mod file can be resolved. It removes things that aren't used, formats it, and it adds a checksum file so that when you download, if there's a disagreement in checksums, that gets flagged by the Go tools. We talked about how the Go tools will rewrite your Go mod file for you. If that drives you crazy and you don't want that to happen and you just want to manipulate the Go mod file, there are low-level tools that will just read, transform, and write out. They won't do any resolution or version bumping at all. And so those are all under the go mod edit command. You can hand edit your go mod file if you want. These are a nice structured way to do it. You can also dump it out to JSON if you want to manipulate that or query it with other tools. We looked at commands for forcing download to the local cache and cleaning the local cache, as well as forbidding network access when resolving modules. And one interesting thing is you can tell it to look at a particular file path to resolve modules. And as it just so happens, the module cache that Go maintains is in the right format to support that. So if you run go mod download, then your module cache will be populated with all the requirements for your current module, and you can point Go proxy at that path, and any resolution that has to be done can do so against the module cache, which is kind of cool. You can also point it at a network location, but that's more complicated, and there's a help topic to find out more about that. All right, that was a whirlwind tour. Maybe 2 minutes for questions, and then we'll probably need to move on.
I have a question.
Yep.
So like the replace directives are pretty crazy. It seems like you can just specify local directory paths.
Yeah.
Are we considering using this particular feature for like dependency injection testing things? Because that
not so much for testing.
you could.
The two cases I know of that are good for are local development, where you wouldn't actually commit the things. You just want to like point to a peer directory because you're working on 2 modules at the same time. And for submodules, which we use in Kubernetes. So if you look at the Kubernetes Go mod file, all the things that are located inside the staging directory use replace directives that point down inside the staging directory.
Right, but I mean, you could use this to just dub something out and then just run your test suite against the thing. That's also.
So I think, yes, you could, but you shouldn't, because there's currently no way for you to, like, if you're developing and you're developing a dependency and a thing that uses the dependency at the same time, there's like no way to get them to talk there's no way to get it to use the thing that you're developing except by using this local rewrite. So if we use it internally to implement things, then people have no tools to help them develop.
Yeah, the local rewrite isn't great for that. The thing we did in the publishing bot was actually use the Go proxy method. So before we publish all of the staging repos out, we figure out what versions they're going to be. We get all the commits lined up. Then we copy them into a Go proxy directory at the versions that we are about to push. And then we run all our tests and builds to make sure that everything builds and tests correctly at those versions. And then we actually push the SHAs live to the repos. So that lets you test what you are about to push without having to like round trip to GitHub and push before you can test, which would suck. Yeah.
Is it, if you wanted to check on all your dependencies like we do with vendoring today, would that just be a Go proxy where you specify the file appropriately, or is?
No, if you want to check them in, you would run go mod vendor and then commit the vendor directory.
Okay.
Yeah. It really has to do with where the modules live. Like if you want them to live like somewhere else, either cached or resolved by a proxy that you control or whatever, then you would use the Go proxy stuff. If you want them committed in a vendor directory, then you would use go mod vendor.
Got it.
So
all right. Oh, go ahead.
Yeah, a quick question. How is branch supported here? If you want to use a branch, a particular version in the branch instead of a master?
I'm most familiar with tags. I think if you specify a branch name, Go will actually resolve that to the head SHA of that branch the next time it looks at the module graph. And so you can't track a branch the way you would want to. You could say, like, I want master of this, or I want release 1.3 of this. But the next time you run a command like go test or go build, it's actually going to resolve that to a SHA and lock you to that SHA.
All right, thank you very much, Jordan. That was super useful. And I think we'll stop this recording here. And